Hello everyone, this lesson is for grade 12C core, okay? Today we're gonna continue from last lessons. The previous lesson we learned about the solving inequalities in equations. But today we're gonna do about integration involved solving equation inequality also, but it's regarding about is involved about absolute values. Okay, so first of all we're gonna talk, they have two cases. Okay, let's see this one. If we let x be a variable or an algebraic expression, and let a be a real number such that a greater than 0. Okay, this one, let's see. This a, I think I will change it to be the small a. Okay, and then this then gonna be small a, and this one have to be greater than or equal to 0. Now they have two cases. The first one say the solution of absolute x, just say if I have absolute x here, less than a, okay, are all values of x that lie between. If I like this one, we can have this one. Just say this one gonna be if x absolute x less than a, okay, if and only if. Another word. If and only if our x gonna be less than a and greater than negative a. Okay, and this one we call double inequality. Okay, and the second case is say if we have our absolute x, okay, greater than a, then if and only if, maybe I lie down. So if and only if and only if, we're gonna have, that means we have x greater than a, or x less than negative a. Okay, in this one we call compound inequality. Compound inequality. Okay, so see, if we have, this one have equal, then you can apply this one as equal sign. Okay, like this one right become less than or equal sign, then this one you just change to be less than equal sign at the same time. Also, if say this one our absolute x greater than or equal to a, right? Then you can just write this one as a greater than or equal sign. This one x become less than, and x less than or equal to negative a. Okay, you can apply if they have equal sign for any equation. Okay, now this can say this is a definition of absolute value. We have two cases. If we have absolute x less than or equal to a, and at the same time, if absolute x greater than a or have greater than an equal sign, also at the same time. Okay, so now we see example. Okay, see some example according this condition, these two conditions. Come back to here. Okay, the first example says solve each inequality. For the example one, question one, okay. So if I say I have absolute x minus 5 less than 2. Okay, this is example 1. So how we solve for the value of x? Now you go back, still remember the previous definition we have. If we have absolute x less than a, right? So we have what? If and only if we got absolute, we got, we're gonna have x less than a and x greater than negative a. That's the definition of the absolute value, one of two cases. Okay, so this is the first cases. So now you apply this one from this definition. Okay, so from this you open the absolute side, right? You're gonna have x minus 5 less than 2, right? This is a now, and this one become greater than negative 2 and greater than negative 2. Then you solve, you remember last class, we solved some inequality questions, use the same technique, use the same way. So this one, we have get the middle term, in middle one's location here to be only 1 plus 1x plus 1x. So then we have to eliminate negative 5. So we plus 5 for every term. So this one gonna be x minus 5 plus 5 because we want to eliminate negative 5. So this one gonna be 2 minus 5. And on the left hand side gonna be, you can say negative 2. This one should be plus because we plus every term. So this one plus 5. So we left 3 here. And now x, this one becomes 0, right? This one becomes 0. So we have x less than, this 5 should be 7 now. This one plus sign, okay? So we get the answer now, x, our answer x less than 7 and greater than 3, okay? Then in this case, so that's the, I mean, the solution set is all real numbers that are greater than 3 and less than 7. Okay, in this case, if we write it down at the notation side, we can have in this way, like this way, right? Say 3, 7. Okay, that's the same meaning because there's no equal sign under here, under the sign less than. So we use the open dot for both sides. So in this case, if we graph it on the number line, if we graph gonna be what? Make it lower, okay. A little bit lower here. So now, so say assume our 0 right here, okay, and 3 here. Our 7 will be here. Okay, now you plot graph on the number line because open both of them, right? So you like open dot, and draw one line. Draw the line. So this graph represents this final answer. Or you can plot another way. You remember another way? You just, because this is open, right? So you like the open side here on the top and the 3, and open side the 7, and then you draw a darker line or another color to label the position of x between 3 and 7. Okay, either way you can plot at this like a pink color here or like the blue color here on the top. Can be either way to plot graph. Okay, so now next example. Okay, give you some more example here. So sorry. So example 2. Okay, if say I have x plus 3 greater than or equal to 7. Okay. Then if you see the sign less than, you lead and. This is and. That means your answer gonna be between, right? Your x gonna be between the number, whatever you solve it up here, you get the number out. But if then your sign become greater than, right? Greater than. This one you will read as a or. If this sign less than here. Okay, now here. This sign less than, you will read as an and. Okay. And this greater than, you will read as a or. So this one come back to here. This second example, absolute x plus 3, okay, greater than or equal to 7. So you will read as a or, okay. Now we solve for this question. From the definition at the beginning, we already discussed, this one is a number 2 condition of the absolute definition, right? So this one you can write it down to be what? 2 cases. X greater than, sorry, it should be plus. So x plus 3 greater than or equal to 7. And another one is x plus 3 less than or equal to negative 7. Okay. So then we solve this question. So we have x greater than or equal to, this one plus move become minus, right? So we have 7 minus 3. Then we have x greater than or equal to 4. Okay, and this one gonna be, we can do right away, right? Become minus, so we have negative 10. Okay, so then you're gonna have 2 equations right here. Next one, we're gonna plot graph. Okay, we're gonna plot graph on the number line. So when you have, we plot graph first and we say, okay, graph here. Okay, so you see this one, x greater than or equal to 4. Assume my 0 is right here. Okay, so my 4 should be here. So x greater than or equal to 4. You see have equal sign, right? So on the top of 4 here, number 4 should be backed up. And they say because greater than, so you draw the arrow to here. Okay, and then next x, this one, x less than or equal to negative 10. X less than or equal to negative 10. So assume my negative 10 about here. Less than, correct? And they have equal sign also. So you write back up. Okay, and then draw the arrow sign. Right now, don't forget our x. Our x right now is real numbers. Okay, our x are real numbers. Okay, so there's a graph represent this one. Represent this question, this example too. Okay, so you can write as an interval also how to write down, like this one, right? So you can write down, say because this is a 4, so you write 4 here, and because 4 go up to infinity plus infinity, correct? So you just write infinity here and open, because infinity have to be open, right? We don't know where the end gonna be end, so just open it, couldn't be closed in the wall. And this one blank it, you represent with a union. Why we use union? Because this one you read all here at the beginning, you remember? So we union. And this one 10, negative 10 included also, include the, so negative 10 is part of the solution. So, and there is a close, so you like close here, and negative 10 here. And because this one go up to negative infinity, so you just like comma and negative infinity, and then open it. So this one means our x equal to this one. Okay, so you can write this as the interval in this pattern also. Okay, or you can write at the like this one at the final. Either way you can write down. So we read this one as a union. Okay, this one we read as a union. Okay. Actually, this sign and mean like an intercept. You can see there will answer between. But if you greater than sign, you will go to the right and to the left. Most of the time, 99%. Okay, but less than, then gonna be between. Answer between. Greater than. So go to the right or and the left, and then you're gonna have union part. Okay, that's a key point is from right here when you see it. Okay, when you see it, that's the one you have to see the sign here. Okay, if less than and greater than or. And when greater than, when you put graph, gonna be the union or, and go to the right or go to the left. If and, the sign gonna be less than, and you use and the answer gonna be between. The value is gonna be between of the two numbers. Okay, this is the two example according the definition of absolute value. Okay, they're gonna have these two conditions. The next one, I would like to go for some word problem for a bit. Okay, so word problems. Let's see. Here. Okay, everyone take a look at here. The application question, like a word problem. I think these two questions, two word problem questions, is really close to our daily life, and then I think gonna be a little easy for you to see, right? How can move here? Yes, can do move. Now we see the first example first, right? Okay. Okay, the first example you see, this is like a comparative shopping. See, really, you are choosing between two different cell phone plans. Plan A costs how many? $49.99 per month dollars. Okay, $49.99 per month for 50 minutes plus 0.4 cent, right? For each addition minutes. And then another one's a plan B. The plan B here is what? $45.99 per month for 500 minutes plus 0.5 cents for each additional minutes. How many additional minutes must you use in 1 month for plan B to cost more than plan A? Okay, then this is very similar to our daily life, like when you go to want to get some service from telephone company, right? But for example, like a AIS, DTAC, or some like a true version from here in Thailand. So they will tell you if you use more than how many minutes, they will charge you how many bahts per minutes. It's the same idea. So this this question they offer you two plans, plan A and B. So the solution you can start by say, because the question that here and the question they're asking, how many additional minutes must you use in 1 month for plan A to cost more than plan A? So you just let monthly cost for plan B. Then from this message, we know monthly cost for plan B greater than monthly cost for plan A. Okay. Then you can find out the equation. We let the minutes used over 500 minutes in 1 month equal to m minutes. And then monthly cost for plan A, we know total gonna be what? You get the 0.4 cents here, time the over minutes here, and then plus the cost you have to pay per month is a 49.99. So you got the plan A, the monthly cost for plan A. And the same thing when you go to find the total cost for plan B. That means you get the 0.45 here, right? They will charge this for additional minutes, right? They will charge for per minute. So time M, the minutes we use over 500 in 1 month. So you time it up, plus the cost you have to pay for plan B is $45.99 per month. So now we get this one. Then you put this plan A and plan B in this inequality, this line. Okay. So then your inequality come up by plan A greater than plan B. So you have 0.4 M plus 45.89 greater than 0.4 M plus 49.89. And then this one you solve equation. Okay. Use how to solve it. You just move 45.89 to this side, become minus. Okay. And then this one move back to this side, 0.4 M move to this side. When you subtract, you will left 0.05 M greater than 4. And then you divide it by both sides with by the number 0.05 for both sides. You will get only 1 M here. And the answer is what? 80 minutes. So we know plan B will cost more when you use more than 80 additional minutes in 1 month. That means that you know is if you more than 80 minutes, plan B will cost more than plan A. Okay, that's the example. I think you can take a look and review one more time. Okay, I will give you handout about this one also. You take a look and review for this example. I think it's not too hard to understand because it's really close to our daily life, right? I think you should really similar to when you go to contract. You want to change the plan, change something. It's a better deal, something from the telephone company. Now you see the example. Another one. This also another example word problem. Take a look at what they say. You go to a candy store. This one talk about the accuracy of a measurement. Okay. Okay, see what they say. You go to a candy store to buy chocolates that cost $9.89 per pound. The scale that is used in the store has a state seal of approval that's indicated the scale is accurate to within half an ounce. Or that means half ounce is equal to what? 1/16 pound, right? So if half ounce gonna be 1/32 of pound. Okay, that's the meaning here. According to the scale, your purchase weight 1/2 pound and cost $4.95. How much might you have been uncharted or overcharged as a result of inaccuracy in the scale? So this question means, for example, like you go to a candy store, you want to, and the price of the candy, like a chocolate, they will charge you 9.89 per pound, right? But then you want to buy only half pound, right? That's half pound. That means equal to 1/32 pounds. I mean 1/2 ounce equal to 1/32 pounds. So then let's say if you buy half pound, right, half ounce, they will charge you $4.95. Okay, but then they say because the maybe the device or equipment they made the tied to weight about the chocolate, there's inaccurate. So in this case, we can have how to say undercharge or overcharge from when you buy this one. it is really similar our daily life. Like for example, when you go to in a market, a supermarket, or some like a by side the road, we're gonna buy some mangoes or buy some durian or something. They have the measurement to weight. Less or more, that's one really is not really not accurate for the weight. So this the meaning is like here. Okay, so in this case, you will get the in this case you will have the absolute x minus 1 or 2. Okay, that's it's a half pound here. Will less than or greater less than or equal to 1 over 32. So 1 less than or equal to 1 over 32 here mean the you gonna read it as a x minus 1 less than or equal to 1 over 32. You can maybe I could go this way. Okay, go down to write it down on the whiteboard. Okay, so from the in absolute inequality there we have like and this one. Then you simplify this, right? You simplify because you find 32 2, you find LCM. Remember we do the shortcut 32 2. So you have 2 1 6 2 1. So your LCM 2 times 16 times 1. So your LCM is 32. Okay, from here, how you do? Okay, from this side, okay. So 1 over 32 is already there, the denominator, the LCM. So this one, 1 over 2, make it 32, so you time what? Time 16, right? So you time 16 top and the bottom. Time 16. So this is gonna be what? 1 over 32 plus 16 over 32. So we have 17 over 32. So this one we have 17 over 32. So this is the same thing, right? LCM is 32. That means you're gonna have negative 1 plus 16 over 32. Okay, same idea how to do, okay? Then we left what? 15 over 32 for this side. So we have 15 over 32. Now we get the value of x now. So our x is what? Right now our x is a true weight of the candy. Okay, our x is a true weight. As true weight. Let x. Okay, we just say let x become the true weight of candy of the candy. Okay. So we know this one. So actually this one tell us what? This become the minimum wage. And this one tell us the maximum wage. Okay. So if this is a wage, the candy, right? So this one, if you time from the question, if you remember, the question they give us what? The candy gonna be, I write down here. The candy gonna be what? Cost, the cost is 9.89 per pound, right? So then this is the wage, then you time it up. Time 9.89 time this one, then you get the cost. What's gonna be? Time it up. But we have if we use 15 divided by 32, right? And time 9.89, you will have this one gonna be 4.6 approximate $4.64. And this one, if you get 17, right? 17 over 32 times this one, the candy per pound, the price 9.89. So what we have divided 17 divided 32 times 9.89. We're gonna have approximate 5.25 dollars. Okay, so this question we calculate, we get this one because we can say less or more when you go to the market. If we made any device or any machine is like inaccurate, you have really, how to say, you have the chance you're gonna get overpay or underpayment. You can say gonna be undercharged or overcharged. Okay, like in this case, this is a maximum. That means the seller can charge us this price, right? If our maximum wage equal to 17 over 2, our cost, the seller is supposed to charge us 5.25. Okay, but then the question, they say if you buy the half ounce, right? You already pay $4.95. Okay, if you buy only half ounce, they charge you 4.95. But in this case, in case for the maximum wage, that is possible can be between, right? For the wage, the true wage, X is the mean, the true wage you should have if the machine or device is accurate. So in this case, that means you're gonna pay, the seller supposed to get your money for this one, right? 5.25, but he or she, the seller, charge you only 4.95. In this case, you gain it, right? You get the undercharge. You understand this one? That means you have the undercharge. That now that in this case you gain it. You gain how much? Right? The seller supposed to get your money $5.25, but you pay only 4.95. So you gain is minus 5.25 minus 4.95. So that means you gain about 0.3 approximate cents, right? So you gain about this one. But if you see this side is minimum, if your wage about minimum 15 over 32, that means and the dollar you have to pay is a 4.64. I mean the you're supposed to pay 4.64, but the seller charge you 4.95. In this case, you have overcharged it, right? So you lost how many? Like a 4.95 minus 4.64. So you lost it about 31 cents. 31 cents. Okay. So then when you do this question, it's like our daily life, correct? You go shopping when you buy vegetable, anything in the supermarket, or even though you buy like by side the road when you shopping around, they have to weigh your thing, right? So when most of them really feel gonna have accurate 100% at the scale, it's always have the inaccurate. So there's a way you can calculate today, and then see you have undercharge or overcharge, something like this. That is for really happen in the daily life. Okay, I think this the word problem for these two questions, the two example is really nice also, because you really can apply to in your daily life when you go out to shopping, so you can compare, right? Okay, so I think this is about the absolute value in the form of inequality, right? Inequality absolute values. So any question So if you have any question, please, or you need help with the question, please. We have line group already. You can line me, or anyway, I can help. Right? You please answer. Ask me the question if you need help. Okay. So I think that is for today for these lessons. Hopefully you understand. Okay. Again, need help, please contact me from the line group or from the school websites, or maybe what else. So far, I think line group, unless you know the Zoom meeting, so we can try from there. Okay, now bye bye. See you next class. Please tell if you need help. Okay, please ask. Bye bye. Good night. Bye bye.